Hi, this was our do now. And then now we're going to do notes. How are you? No one's saying anything and they're making this awkward. Okay, we are now going to 7.6. Go ahead. My arm hurts. Is everybody's foldable all filled out? Do you need to borrow the yellow one to get some of the pages you missed or no? You could pass that around today. Help you study.
What's our snacks today?
We got Gushers, we got Welch's, and
Mary Poppins.
That was me. All through high school, I just ate all day long in every class.
what was for last time? Oh yeah, chicken rice.
I've been buying this chicken and rice.
It's like a half serve.
I agree. I need please.
Yeah, come on. We're out here athleting. Come
I
on.
give you 4 mozzarella sticks for your retired lunch.
No thanks.
Our house is gluten-free because I have celiac, so every time that they have like real chicken fingers and stuff at lunch, Ellie's like, I asked for extra because they had gluten in them. I was so excited.
What's in the bag?
Okay.
I wonder what pure gluten tastes
All right, here we go. It's the protein that helps bread keep its structure, I believe, right?
So you can just make bread soup without
Bread.
just a liquid bread.
No. Liquid bread is gross. The idea. Why are you being so troublesome? All right. Oh, no. Come on. Is this a joke? Stop. I'm about to just draw on the board. Okay, I think we're all right. Aren't you so glad you're following along at home? You must be learning so much. Okay, so let's go to question number 1. We're going to practice finding the derivatives of things that are scary, but ultimately they're not going to be so bad, okay? So it helps if you read it out loud to yourself before you start doing the math, right? So if I read question 1, I would be like, okay, f of x is equal to x squared times. If you're saying one chunk times another chunk, you're going to be using the structure of the product rule. Okay, so I have x squared times 2x minus 3 to the 4th power. So since I've got times 2 different things, I can find the derivative with the product rule. So I got u prime v plus uv prime. Let's find all those u's and v's. So u would be x squared. U prime is 2x. V is 2x minus 3 to the 4th. V prime. Okay. I know we taught the chain rule the long way. Hopefully some of you have started using the shortcut as you go through, right? So the shortcut in this case is we're kind of manipulating around the inner function. So we're going to find the derivative of the outside, treating the inner function kind of like a power rule, right? Because if we let u equal the inner function, we do have something that we can take the derivative of using the power rule. So we're going to drop that 4 down in the front, leave the inside alone, don't touch the inside, reduce the power by 1. Then you're going to multiply by the derivative of the inside. You should always clean this up to move the constants in the front so that way they're like all one nice little thing you can work with. So I would have 8 times 2x minus 3 to the 3rd power. And that's going to be my v prime. So then I'm going to plug this into the structure of the product rule. And I would have u prime v plus u. Okay, try to put these together in a smart way, right? I got x squared, I got an 8. Those are both going to go together out front, right? 8x squared. Okay. Can anyone identify a GCF of this? Like, this is an okay way to leave it, but We want to practice doing this because we're going to be using derivatives to solve in the next unit, right? Yeah, go ahead. 2x is certainly part of it, and then what about these factors here?
2x minus 3.
Yeah, how many can you use? The limiting factor is going to be the smallest number, right? So I've got 2x minus 3 to the third. Good job. Together we have it all. So think about what it would look like if I divided this first chunk by the GCF. It would be like, yeah. So all that's left kind of is 2x minus 3, right? Then in the next one, all of the 2x minus 3s are going to cancel, but I would have 8x squared divided by 2x. What would that give me? Good job. And now, if you had to solve this using zero product rule, you're like, oh, actually, what would this guy become? 6x minus 3?
Wait, what do you just do?
Ooh.
I'm so confused.
So I simplified this to become 6x minus 3, and I just brought it out front because he's smaller in magnitude than that guy. Big factor. Big factor.
Exactly, they're so scary.
That was Damien screaming. You didn't see it because you weren't here. All right. Question 2. I do want to show you this tool. Okay, I don't know if I've showed you this tool just yet, but if I wanted to find the derivative of this guy, I'm going to raise it to the 1/2 power and then take a look, right? So if I'm trying to find the derivative of this and I turn this into x over 4x minus 1 to the 1/2 power. When I take the initial derivative, right, I bring that 1/2 down in the front. I'm going to reduce the power by 1. Hey, no problem, right? Oh, here's the problem times the derivative of the inside. If you're just trying to organize your work and you're like, I need to find the derivative of the inside, I just want to organize myself, you can use notation that looks like this. It's kind of like this guy prime, meaning like I still need to multiply this by the derivative of the inside, but I have to find that off to the side, right? So this notation is like used for organizing your thoughts where you're like, oh, okay, now I can just go over here and be like, okay, the derivative of the inside is going to be found with the, what would you guys use for the derivative of this guy? Quotient rule, right? You're dividing two things. So I would be like, okay. Okay, so the derivative is going to be u prime v minus uv prime all over v squared. Why are you dimming? Are you about to die? Hang on. Okay. So, ooh, a 1. We love a 1. U v prime v squared. Ooh, this one's actually pretty good. What happens to these 4x's? They cancel. So now that's the derivative of the inside. So now I'm going to be multiplying this whole thing by that. Okay, so do you see how that notation could help you keep track of what's going on with nightmare-y things? Okay. So I want to show you how you could simplify something like this. So we just have one singular numerator and one singular denominator, okay? Think about what a fraction raised to the negative first power means. It just means flip the fraction, right? So if I kind of rewrote this guy, maybe I'll just do it over here as this. You don't need to write this down. Just like watch what's going on kind of. Could I not do something like that? Could I do something like that? let me not ask a question in the double negative. Could I do something like that? Yeah, right? Because if you did power raised to a power, it would just end up being to the negative 1/2. So if I have this nested guy in here to the negative first, couldn't I just flip him? And now I have that. And then if I wanted to separate it so that way I have a numerator and I have a denominator, couldn't I give this 1/2 power to both pieces here? Don't write this down because you're not gonna have room. But couldn't I have something that looked like that? Yeah, so then if I wanted to put it all together, when you're trying to rewrite these and simplify these, you want to envision who's in top and who's on the bottom, right? So I have 1/2 times the square root of 4x minus 1 over the square root of x times -1 over 4x minus 1 squared. Okay, can I erase this just because this was my thinking, and now we can meet back and we can copy this down again.
Is a function like that, like this quiz,
On the quiz,
or like just like these like really hard ones?
I will get back to you because I don't remember what's on the quiz.
Okay, and then also like on like any quiz or test, we have to like simplify like that far.
It depends, because if you had to find the second derivative of this, wouldn't you kind of need to do that?
Like a second.
Yeah.
What do you mean second?
It just means like take the derivative again. You'll learn about that after the quiz tomorrow. But, so like in this case,
They made me so scared.
what was the simplification that you needed to do? You had to get that number out front there. Because if you had to do the derivative of this guy again, yeah, it's a nightmare, but you could use the product rule and that's fine. If you had to find the derivative of this, like, LOL, right? So you're going to need to do some math in order to figure out how to find the second derivative of that. I don't think I have anything that bad that you have to find like a second derivative of, but we want to be ready for anything, right? Because that's where confidence comes from. Hey, I saw all the nasty stuff. You can't scare me, right? Yeah. All right, so then you can have something nice like that.
So like if we got this exact function, would we have to do like simplify it that far?
I don't think you would. Like, I think it would either be like, oh, you have to find the second derivative of this, or so then you would be like, oh, I have to reorganize this in order to find the second derivative, or you could leave it as the other thing, you know? I'm sure that's the answer you were looking for, right? How delightfully vague. Okay, let's go to question 3. Question 3, what are you going to use in order to find the derivative of this thing? Well, if you read it out loud in your head, you'll probably be able to figure it out, right? You have f of x is equal to x divided by the square root of x squared minus 1. If I'm dividing, I got to use the quotient rule, right? And then when I set up my quotient rule, I'm going to be like, oh, there's also a chain in there because I got something under a square root. You look physically nauseous. It'll be okay. Here we go. Okay. I'm rewriting this guy as x squared minus 1 to the 1/2, so that way I could take the derivative using the chain rule, okay? All right. Oh my, we're going to need to simplify this guy until we keep going, right? I'm going to rewrite v as the square root of x squared minus 1 because when I plug him into the structure of the quotient rule, I don't know. I feel like it'll be easier to work with. For this one, though, let's see. I've got 1 over, okay, 2 square root of x squared minus 1. And then where would that 2x go?
The x go out.
Yeah. So we're going to put that 2x right up here. Oh, wait, and then what's going to happen there?
Where did the 2x come from?
Times the derivative of the inside. Great question, right?
Oh. Oh yeah, you did.
It's good. Ask these questions.
Because I forgot we like chain rules and
I love it. It's giving me fuel. Okay. So now I've got u prime is 1, b is the square root of x squared minus 1 minus uv prime. So we're going to have u times, oh man, yeah, all over v squared. Okay, so if we had to clean this up,
Wait, what is that? Wait, it's like, is that a b over 1 or x over 1?
it's an x, but his like legs melted.
That's what I thought. Like,
Hang on. There we go. It's probably just as bad. Hold on. Okay. So let's think about what we got. We got the square root of x squared minus 1 minus, what would you guys do with that second piece there? What is numerator times numerator would give you a what? Yup, over denominator times denominator. Okay. We don't have to go any further here, but you could if you wanted. What would you do to simplify this? We're not going to do it because I don't want to be like just going absolutely off the rails with the math here. What could I do to simplify this if I had to? Yeah, so don't write this down, just watch, right? What could I do if I had to simplify this? I could put this over 1, and then what would be the LCD of these two? Right? Or you could do it just up top. Actually, I think if we do it just up top, stuff might cancel. Let me see. So, no, because you're going to do the keep change flip anyway. Yeah, you could do it either way. Doesn't matter. I was thinking there was an easier way, but. Okay? And then what could you do? That would cancel this guy up here, right? And then you would have another additional factor down there in the denominator. You could do that if you wanted to. Totally fine to just leave it here. That's fine. Okay? Disgusting. All right. That's okay. Look at us. We're going through it. We're going to come out the other side. Good. My computer is frozen. I'm going to let my pen charge. Why don't you guys try to set up question 4, okay? Try to set up question 4. Okay, the initial structure to take the derivative of this, yay, we're unfrozen, would be what? What are you guys going to use to get the derivative of this guy, get the structure? What do we plug in into? What structure here? I'm going to read it to you. What?
Product.
Yes, good job. Was anyone like not clear why it's product rule?
You get 2 things multiplied.
Yep. Ooh, what are you gonna do to take the derivative of each one of these little pieces, though? Chain rule. Okay, so I'm going to drop the exponent down in the front, reduce the power by 1, multiply by the derivative of the inside. Let's clean this guy up. I got negative 4x over x squared minus 3 to the 3rd power. Is everyone cool on how we got that? Okay. Excellent. Then v is, I gotta scroll up. Can you guys read v to me? What's v?
X squared plus 4x to the 5th power.
X squared plus 4x to the 5th power? Oh, nope, there's no x there. X squared plus 4 to the 5th power. Perfect. Okay. So now I'm going to take the derivative of this guy just like a power rule, right? I'm going to drop the 5 down. Don't touch the inside. Reduce the power by 1. Multiply by the derivative of the inside. All right, now I'm going to plug these into the structure of the product rule. So I've got u prime v, oh my goodness. I'm going to put this guy over 1 just so I can see exactly what's on the top and what's on the bottom. Plus u, I'm gonna rewrite him as 1 over x squared minus 3 to the second power. UV prime times 10x to the x squared plus 4 to the 4th. Okay, I'm gonna clean that up. I know, it got really small. So now everything that's on top looks like it should be on top, and everything that's on the bottom looks like it should be on the bottom. You kind of just multiply across and just sort everything that way. So now I've got f prime of x is equal to, so now I've got negative 4x times x squared plus 4 to the 5th, all over x squared minus 3 to the 3rd. Don't know why I said 3rd and wrote 5th, plus 10x to the 4th times, I'll be honest, I can't read my handwriting there. What does it say? 10x times x squared plus 4 to the 4th. Whoa, definitely can't read my handwriting there. Hope you can read yours. 10x times x squared plus 4 to the 4th. Okay, all over x squared minus 3 squared. Okay. What could I do if I had to go any further with this?
GCF.
No, choose add the numerators.
Just add the numerators because they have the same denominator.
Do they have the same denominator though?
Oh, I know.
You'd have to do one manipulation, right? I can multiply. I'm going to leave this as is because this is a totally fine answer. I don't have to do anything else with it. What if I had to? In fact, I'm going to write it on the board just so you clearly know that it's not part of the answer, right? So if I had to, what could I do? Get a common denominator so I can combine the numerators, right? And then once I have that, what would I be able to pull out, do you think?
Wouldn't you multiply by only one if you did it for three? Like, why multiply by two?
Hmm?
Like, you multiply by
Oh,
square.
yeah, just one, just to get up there. You're right. So now I got. Whoo! I did like that. All right, what is the GCF? Could you guys think out a GCF here?
Plus
2x.
4 is 4. Plus 2x.
This is no work.
Oh, I can get
Insanity. All right. Yeah, you could pull out a 2x and then 4 of these. Right, if you had to. Looks good. All right, the next one is, IB likes these questions because it eliminates the error of working with lots of different factors and things. It's just testing like your pure understanding of the derivative rules, okay? So there's a whole bunch of evaluations right here that are given. Ultimately, what we want to find is h prime of 2. So these are 4 different iterations of h of x. We're going to find the derivative and then evaluate the derivative when x equals 2. So we're going to use all the rules we got, okay? Look at the structure of 5. To find the derivative of something like this, right? What would you have to do? My pen's being weird again. Let's just talk through it and then I'll write it down in a second. I have a function being cubed. Chain rule. Good job. There's a function in a function. So I would take the 3, I would drop it down in the front. I'll just write it down. No, because then I have to scroll back up to find the numbers anyway. Okay. So I would drop the 3 down in the front and reduce the power by 2. By 1, and it would become a 2. Then I would multiply by the derivative of the inside. So it would be like, oh good, I'm back. Okay, so it would be just like this. Am I changing the inside at all? F of x remained f of x, did not change. However, I have to multiply by the derivative of the inside, so I'm going to multiply by f prime of x, okay? Then, what am I going to do with h prime of 2? Everywhere I see an x, I'm going to plug in a what? Good job. So now I gotta find all these pieces up top. So f of 2 is negative 3. F prime of 2 is 6. 9 times 3 is 27 times 6 gives me 162. Now, unfortunately, is there any way to check your answer with something like this? No. So, can't graph it. You can't do numerical derivative at a point because you don't have the original function. So that's why I do not particularly care for these, but in a pure sense, all right. So we're gonna go to 6. Initial thoughts. What should I do to see what's really going on here?
You should get rid of that, you should turn that square root into an exponent.
Yeah, we could do that for sure. I'm gonna keep my notation of h of x though, so I don't get confused and think I took a derivative when I didn't. Okay. And then now I see that there's a function within a function, so I'm gonna use the
Chain rule.
woo. Okay, let's talk about the derivative of the inside in 1 second. Hold on. Notice how you are not touching the inside when you take the derivative right now. Okay. Now, what is the derivative of the inside? Let's go piece by piece, right? There's a constant out front. We take the derivative of g. What's the derivative of a plain old x? 1. And then the negative 1 drops off. Okay. Now I'm going to put in a 2. Is anyone, just like take a look, is everyone okay with what happened here? Yeah?
Wait,
All right.
How,
No.
is that, like, G, well, how did you get G prime for that? Like, don't you just,
Because if you're working piece by piece, right?
no, on the second piece.
Yeah, so I'm taking the derivative of this part, right? So there's a 4
Like,
out
just
front.
Show me how you found the derivative of the inside part.
Right.
You just made it a derivative of the G of X, like you don't move anything?
Right, because there's just a constant out front, right? So if you have a constant out front, you can kind of factor it out. And then you'll be like, oh, it's going to be 4 times whatever the derivative of g is. Right? Because what's the derivative of x? 1. What's the derivative of 4x? 4. Do you see how, like, that multiplier out front remains?
Yeah, I just didn't know you could just make G of X.
Yeah. Well, we don't know what he is, so whatever he is, his derivative will be multiplied by 4. You look suspicious. So, very suspicious. I like that. That's good. Good to be suspicious. You're thinking. All right. So what do I got here? I'm putting in a 2. Okay. Okay, careful. There's a question like this on the test, and there are so many times kids do the substitution for here and they forget that, like, the x is a 2, right? They, like, plug it in all the g's and the f's and everything, and then it's just 2, like when x is 2, it's everywhere.
What's the mistake?
They, like, leave the x in there and then they get confused, or I don't know. Mysteries abound.
You ever just like grade a kid's paper and you're like, what are they doing? And you just feel like, oh, it's like you can't even tell them.
Yes. I have to grade when I'm alone. The only person I can grade with is Crouch. Because he won't judge me. Do you see what I'm doing here so I can make sure that I get the numbers right? Yeah. I dropped that negative 1/2 so he can be down in the denominator, and then I can evaluate it the way I see it. All right, so now I'm going to plug stuff in. What are all these things here? Oh, I can just look on my paper so I don't have to make you guys nauseous. Okay. G prime of 2 is negative 2. G of 2 is 3. Okay, and depending on whether you canceled the 2 or not, you would have negative 9 over 6 or negative 3 over 2. Okay. Yeah! All right, let's keep working with some of these rules here. Let's look at 7, 7. Okay, what do you want to do to find the derivative of 7? Can you identify an inner function? Ooh, good. If you could identify an inner function, you should probably use the chain rule, right? So I'm going to take the derivative of the outside. Careful about like what that would look like, right? If I don't have like an exponent out there, so I can't envision like doing a power rule workaround, wouldn't the derivative of the outside be this? That's the derivative of the outside, right? Times the derivative of the inside. Are we good with this? Okay, and then now we're going to evaluate when x is 2. F prime of g of 2. So I have to find g of 2 first, and then I'm going to see what that is. G of 2 is 3. So now I'm finding f prime of 3. Do you guys see how that evaluation ended up? Yeah. So f prime of 3 is 4. G prime of 2 is negative 2. So, let me ask you a question. Can anyone put that into a sentence for me? What does that tell us? Let me get you started. The slope of the tangent line at x equals 2 is negative 8. Good job. Do we know what h of x looks like? No. But if we had to write the equation of the tangent line at x equals 2, we could do it now, right? Yeah. Pretty cool. Okay. What about this guy? Ooh, this guy's spooky. He's got a lot of negatives. So I got h prime of x is equal to. This guy looks like a function within a function. He's going to be a chain rule. So I'm going to take the derivative of the outside, don't touch the inside, times the derivative of the inside. Okay. F prime of 3 is 4. Okay, I have a question for you. X equals 2 is like the spot where we are evaluating this guy, right? Could you find the equation of the tangent line when x equals 2? How would you do something like that? Well, let's think about it. I hope the values that I need are in here because I'm just going off on the tangent here. But if we're trying to find the equation of a tangent line, I should set up what? PSE, right? How would I find the point? Well, this is the original, right? So wouldn't h of 2 be found by doing, and that would give me my point on the graph? It would, right? So I don't know if it's going to end up being on there, but f of 2 is negative 3. So f of 3, is f of positive 3 on here? Okay, f of positive 3 is not on here. But let's say f of positive 3 was 8. Wouldn't it be 2, 8? Yeah. Okay. So then if I found the slope when x equals 2 is 24, my equation would just be, oh, sorry, y minus 8. Needs a negative 24, negative 24, negative 24 times x minus 2. Okay, so even though we have no idea what f looks like, what h looks like, you could, if you were given all the evaluations up top, figure out what the equation of the tangent line at that particular point could be, right? Okay. All right, so let's go ahead and finish up these two. All right. What would we use for 9? Product rule. Holy moly, okay. U prime V plus UV prime. I'm going to clean that up just a smidge. Yuck. All right, do the next one. And on your way over to the next one, ask yourself, do you think there could ever be any kind of Sasquatch or Yeti?
Can you go back to the other one?
I can.
Like somewhere like not around
Like Washington State,
here. Yeah.
right?
Either like that or like something like a jungle. You gotta do some kind of.
I want to believe, but I just don't, like, it would need a population for it to carry on, you know? There's no way you can, like, hide a population of those. There's not just, like, one Sasquatch, you know?
It's like a turtle.
It's just a really old turtle.
No, I was saying there should be like a conspiracy like theory about them or something like. Or funny like weird phenomena. So, like,
Yeah, it's called listening to podcasts. No.
some people look too far.
Oh, absolutely. Let's try the next one and then you're good. You're good to go. I can answer questions you might have on this prep materials for the quiz or anything. You guys want to practice big factoring this with me? Yeah, we do. Oh, good. Perfect. I see that there's 2 of these here. And so I'm gonna write those here. And 3 of these. And then if I took those out, what am I left with? I'm gonna use brackets for this guy. Here we go. If I took those out, what would I be left with? Let's see. 3x plus 6. And then plus 4x minus 6. And then if I wanted to distribute and see if anything canceled, I'd have 3x plus 18 plus 4x minus 24. And then I would get 7x minus 6. Oh man, if you had to solve that, wouldn't it be so easy now that you kind of big factored in and you just got, you're like, oh, I'll set each one of these things equal to 0. And happy days. Okay. Go ahead, start your homework. I'll be around to help you if you need it. Bye.